Okay, and we can begin. Hello, everyone. Thank you for joining us today. Welcome to our webinar, Fine-Tuning Llama 3 in 30 Minutes on FPT AI Factory. I am Donald Muratai, and I'm excited to be your host today. Whether you've used FPT AI Factory before or are just starting to explore it, today's session will show you how far the platform has come and how quickly you can create real business value with AI. And our main focus today will be on fine-tuning because across the global AI landscape, fine-tuning has become a critical capability. As organizations race to build models that are not just powerful, but also relevant and domain-specific, the ability to fine-tune foundation models is emerging as a must-have skill for modern AI teams. And today we'll show you just how accessible that process can be. You'll learn how to take Meta's Llama 3 model and fine-tune it with your own data in under 30 minutes using FPT AI Factory. I will start by introducing myself. So again, my name is Donald Muratai. I hold a degree in actuarial science with a minor in data science from the University of Calgary, and I've spent the last 6 years developing AI models in insurance for problems like fraud detection, pricing analytics, and so much more. I've built software and predictive models for insurance companies in the US, like Geico, State Farm, and Allstate. And currently, I live in Tokyo, where I am on the data science team of a global startup known as ULife, where I focus most of my time on modeling customer behavior and so much more. I am also the founder and organizer of one of Japan's largest startup communities, known as stealthfounders.com. So if you're in Tokyo, feel free to join us at one of our future events. And most importantly, I am an AI consultant to FPT, and I will be guiding you through today's session. So before we dive in, let me walk you through today's agenda so you know what to expect. We'll start with a quick overview of what fine-tuning means, and more importantly, why it's becoming a strategic advantage in the world of AI. Next, we'll jump straight into the heart of the session, which is the live demo, where I will show you how to fine-tune a Llama 3 model using a GPU container on FPT AI Factory, and you'll see how fast, scalable, and straightforward it is to customize a frontier model with your own data. And after the demo, we will open up the floor to Q&A session. So please feel free to note down any questions you may have along the way and be ready to ask them at the very end. Following that, we will just wrap up with a few closing thoughts, and you guys can let me know how you're going to get started right after this webinar. Let's begin with a deeper look at what fine-tuning is and why it matters. To truly understand fine-tuning, let's take a step back. How do we build a foundation model in the first place? Well, we begin with pre-training, which is usually unsupervised. At this stage, the model learns general language patterns from a massive corpus of unlabeled data. Then comes post-training, this section, which is about teaching the model how to interact and behave. This is broken down into two key parts: instruction tuning, which is using prompt response pairs to guide how the model should respond to specific instructions, and alignment tuning, which is shaping the model's responses to align with human preferences, essentially teaching it not just what to say, but how to say it as well. So now that we know the motivations behind it, let's try to understand what is fine-tuning. So in simple terms, fine-tuning is a powerful machine learning technique where we take a pre-trained model, typically a large language model, LLM, and adapt it to a specific task or domain. We do this by continuing its training on a smaller curated dataset that is highly relevant to the desired use case. This approach dramatically improves task-specific performance while saving both time and compute resources. So instead of starting from scratch, fine-tuning lets you skip ahead by building on top of a pre-existing state-of-the-art model and adding further training from there using your own instruction data. This is often referred to as supervised fine-tuning. So for example, if you work in the medical field and 99% of the questions you ask AI are medical related, you should be able to fine-tune your data on a state-of-the-art model to focus solely on medical responses. In short, fine-tuning lets you combine the intelligence of a frontier LLM with the uniqueness of your domain, data, and needs. The result, a powerful custom model that speaks your company's language, both figuratively and literally. But why would you fine-tune a model instead of just using the base model that has a larger scope and can answer any questions? Well, first of all, it improves performance and accuracy. By tailoring models to specific domains or tasks like legal, healthcare, or customer support, we can dramatically increase the relevance and precision. A generic model might understand your query, but a fine-tuned one will understand your context. Second is cost reduction and efficiency. Fine-tuned models often require fewer tokens to arrive at the right answer. That means lower inference costs and better use of your computational resources, especially when you deploy at scale. Third is lower latency. Smaller optimized models respond faster and are more suitable for real-time applications. Since they require fewer tokens, response times are quicker without sacrificing accuracy. And finally, risk mitigation. It allows us to reduce bias, improve fairness, minimize hallucinations. By grounding the model in high-quality domain-specific data, we gain better control over its outputs. So now we want to understand why fine-tuning matters. Let's take a look at how it actually works in practice. I want to improve the model's performance on a specific task. I want to do it in a more cost-efficient model. If your current model is underperforming, the first step is to define your vision and scope. This will vary based on your needs, right? Do you need a smaller model for distillation or a more powerful, complex model for reasoning tasks? These types of questions will help you choose the base model, and your scope also determines which fine-tuning technique you use, right? So for example, supervised fine-tuning teaches the model to replicate patterns from labeled data. Direct preference optimization, or DPO for short, helps align the model with human preferences. Once you decide your base model and technique, the next step is to collect a dataset that reflects the behaviors you want the model to learn. After you have the dataset, you use it to fine-tune the base model, which I will show you how to do soon enough. But here is the key part. The third part we really want to focus on is evaluation. You need to ask yourself, did you actually make the model better, or did you accidentally make it worse? And once the evaluation is complete, you can deploy and monitor, and your new fine-tuned model will show you that it has a solid understanding of the fine-tuning process that it gave you. Next slide. Let's now go over using FPT AI Factory's dedicated GPU containers to fine-tune your models. So let's quickly take a look at what makes FPT's GPU containers ideal for fast and efficient model tuning. First, they offer serverless and scalable compute, meaning you don't have to worry about managing infrastructure. You can scale resources up or down based on your workload needs. Next is isolation and security. For each container runs in a fully isolated environment, ensuring your data and training jobs remain secure and separate from the others. They also come with pre-configured environments, including all the popular AI and ML frameworks, so you can jump straight into development without spending time on setup. Startup times are fast, letting you spin up GPU containers on demand and staying agile in your experimentation. And finally, they are flexible, supporting anywhere from 1 to 8 GPUs per container, depending on your job requirements. In short, it's everything you need to train efficiently without the overhead. Now let's talk about how you can actually use FPT's GPU containers in real-world AI workflows. One of the most powerful use cases is modeling and fine-tuning, adapting a foundation model like Llama 3 to your specific domain and task. You can also use them for real-time inference, serving models in production with low latency and high availability. And lastly, there's a suite of development tools built into the containers, from pre-installed frameworks to monitoring and debugging utilities, so you have everything you need to build, train, test, and deploy efficiently. Now let's quickly take a look at the infrastructure that powers everything we've talked about so far. At the core of FPT AI Factory is a robust, high-performance infrastructure designed to support demanding AI and machine learning workloads at scale. We used NVIDIA H100s and H200 GPUs, which are the state-of-the-art, backed by high-end CPUs, advanced networking, and high-performance storage systems. This ensures exceptional speed and scalability. Whether you're training large language models, fine-tuning custom solutions, or serving real-time predictions, But what really makes FPT AI Factory stand out is just the comprehensive ecosystem, which supports the full journey of AI development and deployment. For teams that want full control, the AI infrastructure tier offers flexible options like bare metal servers, GPU virtual machines, and containers, all paired with persistent storage. This is ideal for those of you who want to build and manage their own stacks. If you're looking for something ready to use, the AI platform provides managed tools for the entire MLOps pipeline with FPT AI Studio. That's here. You get seamless access to data preparation, training, fine-tuning, and evaluation. And with FPT AI Inference and AI Agents, that's these two right here, you can deploy models at scale or even build intelligent agents that reason and act. We offer an AI marketplace as well, where developers go and ISVs can access large models like LLMs or VLMs via simple APIs with flexible pay-as-you-go pricing. And finally, we've integrated cutting-edge NVIDIA technologies like NVIDIA NeMo, NIM, and GC throughout the platform for enterprise customers. There's even an option to run the full NVIDIA enterprise stack on FPT's physical infrastructure. So whether you're building, deploying, or scaling AI, the FPT AI Factory provides everything you need in one unified, scalable environment. Now, I'm going to do a demo that takes about 30 minutes of fine-tuning a Llama 3 model on a medical data set. So I'm going to exit out of this PowerPoint, go over to Google, and this is my account on FPT AI Factory. So I've logged in here. This is the homepage. What I'm going to do is spin up a new GPU container for our code where we're going to be running the fine-tuning. Just 1 second here. Okay, perfect. So the way you spin up a new container is you just press this big blue button here, and you can choose the number of GPUs you want to use. You choose the name of your container, and you pick what type of container it is, whether it's a server or where you want to host your notebook. These are templates you can use to speed up the process. I'm not going to do this because I already did it before, just so I could do some of the installations and save you guys some of the time. So this is the container that I've already spun up. It has 6 GPUs, and I have it ready here on my other screen. So I have installed all of the dependencies we need for Python as well as Llama Factory into this container. For those of you that don't know, Llama Factory is a very popular public repository for running LLMs. You can find it online and Google it if you want to learn more. But I made a bash script that basically installs it into my environment, and it's right here in this folder. So all of these assets and scripts and data are related to the Llama Factory repo. Next, what I would like to do is start my fine-tuning. The goal of today's fine-tuning process is I'm going to be using the Llama 3 base model and configuring it to be a medical expert. So I have a data set of medical questions and answers. Basically, I'm taking Llama 3 to med school, and we're going to make ourselves a doctor. So the first thing we want to do is import all of the libraries we need. So operating system, torch, and JSON. Just going to go ahead and run that. And then next, I want to make sure that my 6 GPUs are available in this environment. So I'm just going to run this script that will go into the environment, and voila, as you can see, I have 6 GPUs, and they are all H100s. So I want to first go into my Llama Factory directory, because right now I'm in the base directory. Let me just confirm I'm in the base directory. Yes, I am. But before I do that, let's make sure that I'm using all 6 GPUs for my training. So 2, 3, 4, 5. And we're going to make sure our environment for training the data set has all 6 GPUs available. And we're going to change our directory into the Llama Factory directory. Perfect. We're in there. Now, the model and data set that I'm going to be using, I'm downloading from Hugging Face. So let's go ahead and log into Hugging Face using my token. Perfect. So next, we want to prepare our data set for fine-tuning. So let me explain to you what this code does. It essentially allows you to pick a data set from Hugging Face. That's this one, medical questions and answering, because like I said, we're training our model to be fine-tuned on a set of medical questions. We're going to pick 5,000 samples from it, and the format of this data set is input-output, so it's just instructions on you asking doctors various questions. And this code is essentially going to configure our Llama Factory repository to have this data set ready to be pulled. So I'm just going to go ahead and run it. Perfect. And I can go into my Llama Factory and into data and into dataset info. And you will see here that the very last data set is the medical one. I didn't download, but I configured from Hugging Face. So the medical questions and answers, and you can see that the columns of this data set are just input, output, and instructions. So now we're ready to continue. What we would like to do from here is configure our training. So using the JSON library, I have specified here how I want to fine-tune the model. First thing I do is I pick the base model, which in this case is going to be Llama 3.18b instruct. This is basically a very popular Llama 3 model with 8 billion parameters. That is going to be our base model. The data set, which we just configured, is the medical one that I got from Hugging Face, and the template is Llama 3. We also want to use a low rank adaptation, which is also known as LoRa. This is an adapter that is used to increase our training efficiency. I won't go into too much detail on how that works, but feel free to look into different adapters that you can use for LLM fine-tuning. And then the rest of the configurations that I have selected, so the number of epochs that we use. And finally, we want to put this all into our JSON file in our Llama Factory folder, so that way I can run the script for training. So let's go ahead and run this configuration. Perfect. If you go into this JSON file, you can see that my training configurations have been stored into the Llama Factory repository. And I also have my dataset configuration stored there as well. The next step will be for me to go into my terminal and start the training. So the reason I'm doing this in terminal and not directly on Jupyter Notebook is just I don't want the log to take up my whole screen. So let's go over to terminal. Let's go into Llama Factory. Perfect. I can use ls to check that I'm in the right repository. I am, because it is the exact same files I see here. Then from there, I just want to export my path variables so Python can find the packages I installed earlier. Good. And then I am in the root user, I think. Yes, I am. I need to exit out of the root user to make sure I run this command. Sorry, I should have done this earlier. Okay. Yes, okay, we're still in Llama Factory. And what I want to do is run this code here. So this is the Llama Factory command for starting your training based on a JSON file that you specify. So I created this train llama 3 JSON, and what this command will do is it will run the fine-tuning according to what I have specified in those configurations. These two arguments just specify, for example, the first one says accelerate the downloading of Llama 3 models from Hugging Face, and the second one is the number of GPUs we're going to be using. So since this environment has 6 GPUs, I'm just going to quickly update this to 3, 4, 5, 6. That's right, 0 to 5. There we go. Let's go ahead and copy that. And I'm going to start my training now according to the JSON file I configured earlier. Okay, let's just make sure it starts. Now, as many of you engineers may know, training takes a while. Even though we do have 6 GPUs, this might take about 5 minutes. So while this is running, I am going to quickly go back into the PowerPoint and just give you guys a little bit more detail on the process flow of model fine-tuning and model inferencing on a GPU container. So let's start with model fine-tuning. This flow is used when we want to take a pre-trained model and customize it further with our own data, just like we're doing to make our AI doctor, right? You start by spinning up a GPU container. We start with a GPU-enabled container. This gives us the computational power needed for efficient model training. Then you set up the environment. So I did that before you guys joined with the installation of the dependencies and configuring the libraries and ensuring compatibility with training the pipeline. Next is preparing the data. So we didn't have to do much there because I used a publicly available data set from Hugging Face. Then is preparing training configurations. So these are the training parameters like the learning rate, batch size, and number of epochs. So I showed you guys that in my code. And then start training. So this is the step that we are on right now because the model is currently training the base Llama 3 model on our medical data set. Then the next steps that we're going to be doing after is exporting the model. So once the training is complete, we will export the trained model artifacts, which is usually just a weights file and associated configuration. And last but not least, we are going to push the model to Model Hub. So that way we can use it as a centralized hub for running it in as our server, allowing us to easily access it later for inferencing or even further retraining. And I can also talk a bit about the model inferencing process, which is used when we want to deploy a model and turn it into a live endpoint. So it starts with setting up environment variables. We begin by setting up key environment variables like model ID, API keys, or memory settings, which helps the container know how to operate. Setting up the startup command to download and serve the model. This startup command is responsible for fetching the model from the model hub and preparing the necessary process for serving it. Again, we spin up a GPU container. This time it's for running inference efficiently. This is especially useful for throughput or low latency needs, right? So this container will be different from the one we currently have hosting our Jupyter Notebook file. Then the model will be downloaded from Model Hub and served, which is where the container automatically pulls the model from the hub and starts a server engine like TensorFlow serving or Torch serve. And finally, we want to expose our endpoint, typically REST or gRPC. So that way external applications like a mobile app or something can send data and receive predictions in real time. So let's quickly go, oh, sorry, it's not Q&A session just yet, but we will quickly go back and see how our model training is going. Looks like it may take a while. Okay. Yes. So how much time is left? About 2 minutes. Yeah, basically what's going on right now is our code is fine-tuning the base Llama 3 model on our medical data set. And we'll just wait for it to finish for a few moments here temporarily. Okay, this might take slightly longer than expected. Let's see what we can do in the meantime. While that's running, I can just go over some of the parts on the FPT AI Factory. Like for example, in the AI infrastructure section, you can see all of our containers that we have available. So for this account, there are 7 containers, only one of them is running. If you wanted to stop a container, you just press this button. That will allow you to stop incurring costs for your hourly rate of running the GPUs. Most of my containers that I've run in the past are just Jupyter Notebook containers, but I will also spin up one in a bit for serving our model. In the model hub, this is where you can see some of the previous models that I've hosted. So I currently have one available right here, but I am going to be making a new one. Actually, let me just delete this one so I can make it from scratch, confirm. Perfect. I think that was incurring some extra costs on my end. So good thing I noticed to delete it. And then this is a DeepSeek model that I've spun up as well. Let's see. So after this, the next step after the training is done will be to merge the LoRa adapter. So we are currently fine-tuning this model with the LoRa technique, which I spoke about earlier. That is the low rank adaptation is what LoRa stands for. And what we want to do is we want to merge this back into the model. It's basically setting up the configurations so that way the model is hosted with this adapter attached. Okay, I think we're close to being finished. How much time is there? It looks like it's about 5 minutes. I can give a brief overview of what we've done so far, just as a quick recap while we wait for this to finish. So as mentioned, step one was installing our dependencies. So we switched to the root user to make sure that we installed everything we needed for Python in the container. And then this install Llama Factory code, I can show you. It is a bash script I wrote that goes into the public GitHub repo for Llama Factory and just clones it into our current server. And then it also installs Hugging Face Hub, which is where we found our data set. The imports are just some Python libraries that we need for this project. So OS is typically used to switch your directories. So I've switched into the Llama Factory directory and out of it several times. Torch is just how we train our model. It is a very famous AI and machine learning library in Python. You can use it for things like computer vision and training models. And JSON is just the library that we use to store our configurations into the Llama Factory folder in JSON files. So you do that with json.dumps. And then after we did that part, we prepared our data set for fine tuning, which was selecting the data set from Hugging Face and picking all of the configurations for it. So we chose the formatting, split, the number of samples, the subset. Okay, so this is pretty important. This data set has a subset called Chat Doctor. So it's basically when people are asking questions to a medical doctor, and it's in the form of questions like, hey, doctor, what do I do if my left arm is hurting? And then it has a response of what that doctor gave in that case. So we are basically updating Llama 3 to focus more on the 5,000 questions and answers that I gained from this data set. And then we save that data set into our configurations for Llama Factory. Let's see how we're doing. And after that, we updated our training configuration. So I created this dictionary, which is later going to become a JSON file for everything we want in terms of fine-tuning our model. So we're using supervised fine-tuning. Train is set to true. This is the base model that we chose. But you could have really chosen any model. Like, for example, if I wanted to use one of ChatGPT's models as my base model, I could have done that as well. The dataset, which is the medical QA dataset, the prompt template here, the fine-tuning type, which is the adaptations, sorry, the adapters that you plan to use, and how many layers are you going to use it on, and I specified all of them. Let's see how we're doing here. Okay, it looks like we have about 1 more minute left till the training is done. Yeah, this is why we rent out GPUs, right? Because we don't want to wait hours for something like this to happen in our own home. It seems like a long time, but this is still a fraction of what it would happen if I was to train locally. And remember that the Llama 3 model is 8 billion parameters, so it is expected to take quite some time. And I think we're almost there. And so after training, the last part we did was just select the number of GPUs we're using. We ran the train command for Llama 3 and we specified where our training configurations were. And next we are going to be merging the LoRa adapter. So let's see, 40 seconds left. Almost there. This is good. As you can see, our loss is decreasing, which means that the accuracy of the model is going up with every epoch. And oh, looks like it's almost done. Yeah, perfect. Training has been completed. Okay, next. Now that our training is done, we have a model stored in our cache. And what we want to do is merge the LoRa adapter onto it just to increase the efficiency. So I'm just going to run that. Okay. And there should be a new JSON file here. So this is our merged instructions for combining the fine-tuned model with the Llama or LoRa adapter. And so what I want to do is start the merge according to these configurations that I just stored in that JSON file. So let's go over here. I am already in Llama Factory. And I will start the merge. Let's make sure to choose all of our GPUs, all 6 of them. And what this is going to do is it's going to take our model from our cache, merge the LoRa adapter to it, and then store our model directly in our folder structure. This may take about a minute. It's definitely much faster than the training. And let's give it a few moments. Perfect. So as you can see here, there's a new folder created called Llama 3 LoRa Merge. So this is our model, right? And we actually chose, I believe, 2 gigabytes per shard. And there's 9 different shards in here. So that means that our model in total is about somewhere between 15 to 18 gigabytes. And what we want to do is we want to now host this model. So this is the Llama 3 model fine-tuned with the medical data. And we want to now host it on a server so that way we can ask it questions as if it was a doctor. So to do that, we are going to host it on Model Hub. And I'll show you here on Model Hub. I only have this DeepSeek model, but I'm going to create a new hub for this new model. So to do that, I first want to install the Model Hub SDK on our machine. So let's go back to the root directory so that way we can install the SDK. And let's do that in the root user. So this code here is to install the Model Hub SDK, which allows you to send models directly from your library into the Model Hub here. So it's going to show up there. Now this download should be fairly quick. Let's give it a moment. Done. Okay. The next step will be for us to specify our environment variables. So that way our code knows how to interact with FPT AI Factory's Model Hub. And I have stored these environment variables in a bash file because I don't want to share my tokens with you all. But I will go ahead and run this. So this will basically just define my environment variables. Done. And then next, I want to make sure to create an empty model in Model Hub. And this is going to be a placeholder just to hold all of the files that I just created. So let's run this code. And I basically use the Model Hub SDK and I specify a model name, which I will just call it Llama 3.1 8 billion parameters medical. So let's go ahead and run this. And what this code is going to do is it's going to create an empty model with nothing in it right here. So I'm just going to refresh my screen and voila, the name I specified is available. As you can see, it is 0 parameters because it's empty. There's nothing in here. The way a model works is you can see the different versions of it. So there's no versions found because this is just a skeleton of a model. So our goal will be to place our fine-tuned model in here. So now that I have created an empty model, I want to create a version, V1 we'll call it. But to create a version for the model, we need to know its model ID. So we know where to create the new version. So if I run this code, I can get the model ID, which is right here. I'm going to go ahead and copy this ID. And I'm going to paste it into this next command, which is to create a version in the model with this ID. And the version name is going to be called V1. So let's go ahead and run this command. Perfect. So I have created a new version. Now I'm going to refresh this page. And if I go into versions, now you can see that I have a version created for this model, but it's still empty. There's nothing in here. So now that I've created a version, my goal is to add this fine-tuned model into the Model Hub. And so the way I do that is I need to get the version ID. And so the way you get the version ID is you run this command with your specified model ID. So I'm going to copy this, press paste. Okay, this is the version ID for our model. And as you can see, this is the version ID for version 1, which I just created. And I'm going to paste that in here for this next command. And don't forget to update the model ID as well for this next command. Okay, so this is the final command that we're going to be running using the Model Hub SDK. And what it's going to do is it's going to upload the model that we currently have stored in this file path, Llama Factory, Llama LoRa merged, Llama Factory, Llama LoRa merged. This is the model that we just fine-tuned. And we're going to throw it into here. So let's quickly do that. Copy, paste, enter. This may take a few seconds. Okay, so it's uploading all the shards. Done. Okay. Now, if I press refresh, look at that. So you can see this model card. V1 is now sorry, I didn't show you good enough. It's a 15 gigabyte model, which is what I predicted. And you have all of the weights and other model files stored in here. So this model is now ready to be served. And what we want to do next is actually create a GPU container for serving the model. So that way you can actually use its endpoint to ask questions. And so the way you do this is we're going to go and do what we did at the very first step, create a new GPU container, but instead of using it for the notebook, we're going to create one for the model. So let's press create. We can call it Llama 3 medical server. We only need one GPU because it's just to answer questions. We'll use the template for VLLM OpenAI. We will give it 50 gigabytes of memory capacity. We only really need 16, but I'll just do 50. And then the most annoying part here, I will have to type out all of my environment variables. But this is done purely to make sure that there is no errors. Because, for example, if you were to upload an env file instead, it's very prone to errors. But this specifies that like there is a one-to-one mapping between each variable and value. Okay. So we're going to get the space URL, the tenant ID, the space token, the model ID, which I am just going to grab from here. This is my model ID. Copy, paste. And the last thing which we need is the version ID for the model we just uploaded. Copy, paste. Okay. And then for the startup commands, so this is upon starting this server, I am going to run a bash script, which will install the Model Hub SDK. So that's the same SDK that we use to upload this model, and connect VLLM to it. So we can use this as an endpoint. We don't need any arguments for this command, so I'm just going to remove all the arguments. And we're going to go ahead and create container. Okay, so now as you can see, we have a VLLM container being created. So it's different from our Jupyter Notebook container. It doesn't need 6 GPUs because we are not doing any training on it. We're just using it to host our model. So this may take a couple seconds. I'll do a quick refresh. Okay, look at that. So our model container is running. We can quickly check that it is accessible. So if I just click this URL, sometimes it takes a while. It probably might take a minute. Actually, usually if I open it up in incognito tab, it works. Sometimes it takes a while for the HTTPS to load. Yeah, we're just gonna have to wait a couple seconds. So it does take a bit of time for the endpoint to work. We'll just wait a little bit longer. Hmm. As you can see, my environment variables and startup commands are specified here. So this is what the container overview looks like. You have your specifications on how many GPUs you're using. So I'm using one H100. The RAM available, the disk space, 50 gigabytes, but I only really need 15.4. Okay, let's see if the incognito version works. It usually takes about a minute. It's taking longer than I'd hoped. Okay. Okay, perfect. So now it's up and running. If you do /v1/models, you'll be able to see that I have this space ready in the /workspace folder of this server, and I can store a VLL model in here. So what I'm going to do next is run this code for inference. Basically, what I'm doing here is I am going to send the headers and payload of our model. So that way I can make a stream of questions and answers. Right. So let's run this code. So this is just defining the function. It's not actually using it. Next, I want to point to this -workspace folder, as I showed you guys a little bit earlier. -workspace is where our model is going to be stored. Models. Yeah, as you can see, it's here in root folder -workspace. And let's also make sure to update the URL here. So v1, I don't need models. Okay, run. And let's ask it a very simple question, which I pre-wrote down. So we're going to ask the model, if you're a doctor and I have a medical question about having a cold and I cough a lot and have a little bit of chest pain, please help me. So let's go ahead and ask that question, and we're going to print out the response. And look at that. So this is using our API that is currently hosting our model. And we have asked it a question, and it gave me a response of, hi, Derry. I guess it thinks my name is Derry. I can understand your concern. You have upper respiratory tract infection. It is common in this season. I'm not going to go over the entire response it's giving me, but as you can see, it's a very medical related response. However, we don't know if this is good or bad. Llama 3 might have been able to give me this exact same answer. So the next thing I want to do is just compare this performance to the original model. So let's quickly run a script in our terminal to host our original model. CD admin. CD. Okay. Yeah, we're gonna run this bash file that I created earlier. Serve model. I can show you what it is. It basically will host the base Llama 3 model. So that way we can compare the base Llama 3 model to the one that we're serving with our fine tuning done to it. And this may take some time. And what we want to do is we want to compare that model's performance to the one that's being hosted at this URL. So we're going to compare our fine-tuned model to the base Llama 3 model. Okay, nice. Yeah, let's run this. And I'm going to ask the same question of both models. If you're a doctor, please answer, I have a cold and a lot of chest pain. And let's see what the two models give me. Okay, so the fine-tuned model, which we pre-trained on our medical data, gives us this answer. Thank you for your query. I've gone through your query, cold, cough, chest pain, and fever are symptoms of respiratory tract infection. Okay, so it's very specific, and you should avoid smoking, avoid stress and tension. It gives you actionable tips. Whereas the original base Llama 3 model, first of all, the response is massive because non-fine-tuned models don't really know when to stop their questions. And it gives you a more generic response. Like if you have a cold, here are some common causes. It's going to give you every single possible answer. It's up to you on whether or not the fine-tuned model is better, right? At the end of the day, it depends on your use case. For me, I think this is a better response because it's more actionable and it gets right to the point. But sometimes you may need something more generic. That concludes the end of our demo. So now what I want to do is open up the floor to some questions for everyone. And the team will be able to help answer a lot of the questions that you have as well. So we have a good group of people here. Alfie has a question. Hello, Alfie.
Hello, can you hear me?
Yes, I can hear you.
Yeah, thank you so much for your presentation. Actually, I have a question that why my company chose to fine-tune a model like Llama 3 instead of using it out of the box. Can you share a little bit more?
Yep. So you're asking why would they do something like this?
Yes, I mean, why don't we just use the Llama model without fine-tuning?
Yep, that's an excellent question. Thank you for asking. I have a slide here where I gave some of the core reasons. Like, for example, accuracy is improved because the Llama 3 based model is trained on an unlimited subset of questions and answers for any domain. So if you need something more accurate because you're working on something specific like construction or medical, your performance is going to be a lot more accurate if you make sure that it's working with domain-specific knowledge. Cost reduction, as you saw in my comparison, the tokens that came from the output were much smaller and more concise with the fine-tuned model. So it will actually save you. As you can see, it's about 1/4 the cost. So it'll be 25% of the cost of the answer to the base model. Lower latency, so it'll be faster to load, just one of the main reasons being shorter answers and fewer tokens. And finally, less hallucinations because your data is more focused on your very specific use case. Yes. Ellie Nguyen has a question.
Hello, can you hear me?
Yes.
Okay. First, thank you so much for the presentation. I learned a lot. So my question would be, could you explain in detail how tools like FPT GPU container or the platforms like FPT AI Factory help simplify or like speed up the fine-tuning workflow?
Perfect. So the question is, how do tools like FPT AI Factory speed up the workflow? I actually want to defer this question to one of my colleagues, Mr. Tian, if you can go ahead and answer.
So, hello everyone. So, let me introduce myself. I am T. I am an engineer from the Factory team. So, I will answer your question. So, tools like FPT GPU containers or AI Factory platform save time and remove the setup headaches for everyone. Instead of spending days installing dependencies or managing GPUs, users can start training immediately with the ready-to-go environments. So these tools handle GPU application and scale across the machines and integrate with popular libraries like PyTorch or Marketplace. So that means the faster experiments and easier debugging for everyone, and less time dealing with the infrastructure. We do it for you. So the platform removes friction from the engineering process and allowing ML teams to focus on model quality and innovation rather than the lower level DevOps operations.
Perfect. Hopefully that was a sufficient answer, Ellie.
So I
Yeah,
hope this
that's
answers.
good. Thank you. Thank you.
Thank you. And Mr. Hung, you have a question?
Yes, thank you for your presentation. I'm also like a software engineer currently working on integrating LLMs into internal knowledge management tools. And one challenge we have faced is deciding between retrieval-based methods like RAG and fine-tuning LLMs, especially when optimizing for both cost efficiency and performance over time. So we have experimented a bit with RAG pipelines using vector databases and also look into fine-tuning smaller open source models. So my question is, in terms of cost efficiency and performance, how do you decide whether to fine-tune a model or use retrieval-based methods like RAG instead?
Yeah, actually, I know Tian was working a lot with RAG models. Do you have an answer for that, Tian?
Oh, sure. Thank you for your question. So, if your data changes a lot, or you just need to plug in the fresh knowledge like FAQ or documents, so RAG is a great option. It is fast and cheaper and flexible. But if you want the model to deeply understand your data, or structure, or follow the specific formats, or perform a task really well, so then fine-tuning is usually worth it. So it costs more upfront, but it gives better performance in the long run. So many teams actually use both together, fine-tune for behavior and the RAG for up-to-date knowledge. I hope this helps. Yeah.
Perfect. Is that sufficient, Mr. Hung?
Okay, that makes sense. Thank you.
These are great questions. I know we're a little bit over time, but we have a couple of extra minutes if anyone has any more questions. Going once, going twice. Okay, then I think that's a wrap. If you guys have any further questions, please feel free to follow me on LinkedIn. My name is Donald Murtai. Otherwise, make sure to check out our website at FPT AI Factory, and I look forward to chatting with you in the future. Thank you, everyone.